So the next topic in class 11 chemistry is equilibrium. Okay. So equilibrium we divide into actually two parts. One is chemical equilibrium and the second one is called ionic equilibrium. Okay, ma? So first of all we will study about chemical equilibrium, then we study about ionic equilibrium. Okay. So first of all, if I study about a chemical reaction, okay, so chemical reaction I can call it can be of two types. Clear? One is reversible chemical reaction and the second one is irreversible chemical reaction. Chemical reactions, they can be of two types. Okay, one is reversible chemical reaction and the second one is called irreversible chemical reaction. So irreversible means what? A can form B. Okay, so it means that this reactant, it can form this product B, but simultaneously B cannot form A. It means reaction is occurring in only one direction. It is not occurring in the opposite direction. That type of reaction is called as irreversible reaction. Okay, ma? So opposite process does not occur simultaneously. Simultaneously means what, ma? Simultaneously means what? At the same time. Okay? At one time only A can form B. At the same time B cannot form A. Then the type of reaction is called as irreversible chemical reaction. Okay? Now coming to reversible chemical reaction, so A can form B, at the same time B also can form A. At the same time I am saying. What is meant by at the same time? At the same time means reactants, they are reacting to form products. At the same time products again they are forming the reactants. If both processes, if they are happening simultaneously, then that type of reaction we can call it as a reversible chemical reaction. Are you able to understand, Amma? So therefore what should happen? So both forward and backward reactions should happen simultaneously. Should happen simultaneously. Simultaneously means at the same time reactants are forming products. Products also they are forming the reactants. Then this type of chemical reaction we can call it as a reversible chemical reaction. Okay, ma? But the rate of reactions may be equal, may not be equal. So make a note of that point also. So here only you write down, ma. Here I am writing the into mark. Here you write down. Okay. So what shall we write? But rate of reactions, okay, may be equal or may not be equal. Okay. What is meant by rate of reactions may be equal or may not be equal, ma? So the rate at which products are forming and the rate at which again reactants are forming, they may be equal, they may not be equal also. Okay. But definitely this is called a reversible chemical reaction because products are formed from reactants, reactants are also they are formed from products. Understood, ma? Both are happening at the same time at the same place. Then it is called as a reversible chemical reaction. Understood, no? Make a note. Now see. So now let us discuss what is meant by equilibrium, and at equilibrium what are the conditions which will exist. Okay, ma? So first condition is at equilibrium we can say that when delta G becomes 0, the reaction is in equilibrium. Reaction is in equilibrium. Are you able to understand, ma? Do you remember what is delta G? Change in free gives free energy. Okay, ma? So when change in gives free energy, when it becomes 0, then I can say that the reaction is in equilibrium. First point of equilibrium, first nature of equilibrium. Or we will try to understand this one by drawing a diagram. See here. So consider this is a delta G, change in gives free energy on y-axis, and this is the time which is taken on x-axis. Okay. So let us consider a reaction is happening like this. Okay, ma? So if I draw a graph between delta G and time in a particular reaction, this is how delta G is varying with respect to time. Then where is that position where equilibrium is present in the reaction, ma? Ee graph lo equilibrium ekkadundi? When delta G becomes 0, then reaction is in equilibrium, no? Where delta is 0. Delta G is 0 at this position. Okay, ma? So here I can say reaction will be in equilibrium. Are you able to understand, ma? So this is the position where reaction will become equilibrium. Okay. Second point. Now let us see what happens at equilibrium. At equilibrium, okay, ma, the rate of forward reaction is equal to rate of backward reaction. Are you able to understand, ma? So this is the most important point or characteristic of equilibrium. Okay, ma? So we are studying which kind of reactions? We are studying about reversible reactions, no? Reversible reaction. Reversible reaction means what? From reactants, product should form. And from products, reactants should form. Are you able to understand, ma? Kya ho chalta hai, ha? Kahi ko sound? Are you able to understand? So see, ma. So at equilibrium, rate of forward reaction will be always equal to rate of backward reaction. Okay? So you can also write it as dx by dt of forward reaction is equals to dx by dt of backward reaction. Okay? It means what is the rate the products are formed, in the same rate reactants also will be formed. That is called as rate of reaction. Are you able to understand? So what is the amount of products which are formed per second? Same amount of reactants are also formed in the same 1 second. Okay? Then that is the characteristic property of equilibrium. So rate of forward reaction is equals to rate of backward reaction. Second point. Okay, ma? Third point is as rate of reaction is the same, clear, ma? Concentration of reactants and concentration of products remain constant. Okay, ma? This is another point which we have to understand in the case of equilibrium. Okay, ma? They remain constant where? They remain constant at equilibrium. This point we should not forget. Okay, ma? So what is the amount of reaction which is happening in forward direction? Same amount of reaction is happening in backward reaction also. So therefore what happens to the concentration of products and concentration of reactants? Ma? They should remain same. Okay, but it doesn't mean that concentration of products and concentration of reactants is equal. That is not the meaning of it. What is the meaning of this statement? Whatever may be the concentration of products, it always remains constant. And whatever may be the product of concentration of products, it always remains constant. But the concentration of products and reactants, they may be same, they may not be same. That is the condition. Are you able to understand? Concentration is equal, undachchu undakpochu, adi vere vishayam. But whatever okay, ma? So understood, Amma, what is happening? So you should not be confused by this equation, ma. Are you able to understand? So in this statement, I never said that concentration of reactants and products, it is equal. Okay? I am saying that whatever may be the concentration of reactants, it remains same. And whatever may be the concentration of products, it remains same. Are you able to understand, ma? That is the meaning of this. Or let us write in the form of some mathematical representations, ma. So I can write, okay? So let us consider this is the reaction which is happening, ma. A is converting into B, or A is forming B, and B is also forming A. This is the reaction. So this is a reversible reaction, no? So what is the meaning of this third statement is, concentration of A, it is a constant. So if I write brackets of A, what is the meaning of this one, ma? It means concentration. Concentration of A is a constant. At which position? At equilibrium. Are you able to understand, ma? When reaction is in equilibrium, concentration of the reactant will become constant. Okay. Similarly, concentration of product also will be constant again at equilibrium. Okay. But the relation between concentration of A and B is, okay, so A, concentration of A can be equal to concentration of B. This is possible. Concentration of A is greater than concentration of B. This is also possible. Okay, ma? Concentration of A is less than concentration of B. This is also possible. Anything is possible. Okay? Concentrations may be different or may be equal also. But what is the point we are trying to understand here? Whatever may be the concentrations, those concentrations, they will remain constant. Okay? So height of myself and height of Umesh, they are constant, you consider. It doesn't mean that my heights are equal. That is not the meaning of this one, no? It means that even after 10 years also, I will be at the same height. Even after 10 years, Umesh height also will be the same. Are you able to understand? So heights are same, but it doesn't mean that they are equal. So that is the meaning of point number 3. Understood, no? Make a note. Okay, now see. So now we will try to understand this equilibrium concept by using this graphs. Okay. So at equilibrium, so on y-axis what I am taking, on y-axis I am taking rate of reaction, and on x-axis I am taking time. Okay. So this is one graph which I can draw. And what is this one? This is rate of forward reaction. Okay. Can you say why I have drawn the graph like this, ma? Anybody, can you say? So what is the meaning of this graph? As the time passes, the rate of reaction reduces. That is the meaning of this one, no? Because initially when time t is equal to 0, here time is equal to 0 only, no? At this position, the number of reactants, they will be very large. Initially, the reactants are in large quantities, no? But as the reaction happens, products will increase, reactants will decrease. That is what happens, no? So that is why I have drawn the graph like this. Are you able to understand? So if reactants are reducing, it means the products, they are increasing. So therefore, the second graph which I can draw is like this. This is how I can draw. Okay. And what is this graph? This is the rate of backward reaction. Are you able to understand, ma? Rate of backward reaction. Okay. So initially, the rate of forward reaction is very large, and the rate of backward reaction is 0. Why rate of backward reaction is 0? There are no products, no? Anna Subara. Baunava? Anta baunar kada? Pellam pillalu. Levate pilla pellalu. Andaru baane unnaru kada. Mari vinaya. Okay? Sima. Initially, reactants were very large. Products were not there. Okay? So the rate of forward reaction will be very large, but initially the rate of backward reaction will be 0, and slowly it increases. Okay, ma? So we will get one position where the rate of forward reaction and rate of backward reaction, they are equal. Okay? And this is that position, no, ma? This is that position. So this position we can call it as equilibrium. Are you able to understand, ma? So this is the position where the rate of forward reaction and rate of backward reaction, they will be equal. That is the meaning of it. Understood, no? So therefore, what are the note points I can write here? Note points are that at t is equal to 0. At t is equal to 0 means what? When reaction started. That is the meaning of it. Okay, ma? When reaction started, only reactants were present. Only reactants were present. And what about products, ma? Products were absent. This is a very important point, ma. Clear? At the start of the reaction, only reactants will be there. There will not be any products. Okay? So that is why the rate of forward reaction will be very large initially, and rate of backward reaction will be very small. Are you able to understand? But as the time passes on, we will get one situation where the rate of forward reaction, backward reaction, they will be equal. That situation is called as what you call the chemical reaction existing at equilibrium. Okay. Similarly, if I draw a graph like this, okay, ma? So this is rate of reaction, this is time, okay, ma? So if I draw a graph like this, then what do you understand? If I draw a graph like this, what do you understand? So rate of forward reaction is greater than rate of backward reaction at any instant of time. Okay. So both, they are not getting equal. Are you able to understand, ma? Similarly, if I draw one more relation, one more graph like this. So this is the rate of reaction on y-axis, and this is the time on x-axis. Okay, ma? So if I draw a graph like this, then what is the meaning of this one? So this is the point where the reaction is in equilibrium. Okay, ma? This is the situation where reaction is in equilibrium. But after that, the rate of forward reaction is lesser when compared to rate of backward reaction. Okay, ma? So after this, the reaction is not in equilibrium. Only at this position, it is in equilibrium. Are you able to understand, ma? So here, it is not in equilibrium. Understood, ma? So therefore, by looking at the graphs also, we can understand where the reaction is in equilibrium, where the reaction is not in equilibrium. Understood, ma? Make a note. స్కేల్ అందుకోండి, ఆన్ చేసినా ఇంకా దానిలోనే ఉంది ఫ్యాన్. See, so this is the given question, and these are the 4 graphs, 4 options which are given, and we have to select one correct graph out of these 4. Okay, so see. So reaction is, this is the reaction. 2 moles of reactant, it will give rise to 1 mole of product. That is the meaning of this one. Okay, ma? So here a stoichiometric coefficient is 2, here a stoichiometric coefficient is 1. It means that 2 moles of reactant, it is giving rise to 1 mole of a product. So that is the first information which we have to write. So 2 moles of reactant gives rise to 1 mole of product. That's it, Nama? Okay. Now see. So initially how many moles of A is present? 4 moles of A is present. So A decomposes and 1.5 moles of B is formed at equilibrium. So at equilibrium what is happening, ma? At equilibrium 1.5 moles of B was formed. Then how many moles of A is present at equilibrium? I don't know. I don't know. Are able to understand, ma? Are able to understand what is the meaning of question? Initially 4 moles of A was there. Then how many moles of B will be there? 0. B is reactant product, no ma? Initially will there be any product? No. Akko. Right. Okay, ma? So initially product will not be there. Are able to understand? Only reactant will be there. How many moles of reactant was there? 4 moles of reactant was there. And 0 moles of product will be present initially. Then at equilibrium, how many moles of B was formed? 1.5 moles of B was formed. Then how many moles of A will be there? That still we don't. So first of all I have to calculate that one. No? Then I can draw any graph. Then I will check which graph will be correct. Understood, Nama? And see, ma, here in the graph, this is not the graph related to rate and time. Previously also we studied some graphs, no? There we studied graphs between rate of reaction and time. But this is which graph? Concentration of reactants and products versus time. Are able to understand? Okay, now see. So therefore, initially means what? At T is equal to 0. Okay, ma? 4 moles of product. 4 moles of reactant was present. Okay. And how many moles of product was there, ma? 0 moles of product was present. Understood, no? Now let us write this one mathematically, ma. So 2A gives rise to B. So listen very carefully. So therefore I will write at T is equal to 0. That is when chemical reaction is about to start. 4 moles of A was present and 0 moles of B was present. Are you able to understand? So then actually in the chemical reaction what is happening? 2 moles are disappearing. 1 mole of product is forming. This is what is happening. No? So how many moles of reactant should disappear? 2 moles. But how many moles of product should form? Only 1 mole of product should form. Okay. So therefore what I do is I will consider at equilibrium. Okay, ma? So I am taking 2 intervals of time. 2 instances I am taking. One instance is when time is equal to 0, that is when reaction has started. Another condition is at equilibrium. 2 conditions I am taking. Are you able to understand? Okay. At equilibrium I will write 4 minus 2x. Now can you say what is meant by 4 minus 2x, ma? 4 minus 2x means what? 4 is initial number of moles. X means the number of moles which have disappeared. Understood, no? But how many moles can disappear in the reactant? 2 moles can disappear. Then only 1 mole of product will be formed. Therefore, here I have to write x, no? Clear, no? 2x is disappearing, x is forming. Are you able to understand? Is it correct? How can you say it is correct? Because that is the reaction which is given, no? 2 moles of reactant will give rise to 1 mole of product. So x moles of product was formed. Then how many moles of reactant should disappear? 2x moles. Satisfied, no? So 4 minus 2x is the present number of moles now. And x is the present number of moles in product. Are you able to understand what is happening? Okay. And x value is how much, ma? X value is 1.5, already given, no? X value is 1.5 at which position? At equilibrium. Okay. So therefore 4 minus 2x, 4 minus 2 into 1.5 is how much? It is 4 minus 3, it is 1 at equilibrium. Are you able to understand? So this is related to B and this is related to A. Clear? So therefore at equilibrium, how many moles of product is there? 1.5 moles of product is there. How many moles of reactant is present? Only 1 mole of reactant is present at equilibrium. Are you able to understand? Now this is the data which I got now. By using this data, we have to draw a graph, and then we have to check which of the graph will be satisfied. Okay, now let us see. How can I draw the graph? Shall I rub this one? Any doubt here? So in solving this kind of problems, 2 situations you have to take now. First situation is when time is equal to 0. Okay, and second situation is at equilibrium. These are the 2 conditions you have to take always. Understood? No? Now see. So maximum number of moles 4 only now in either reactants or products. So therefore concentration I will take 4. Number of moles is nothing but concentration also. No? Number of moles equivalent to concentration. So 4, 3, 2, 1, 0. I can draw like this. And this is the time taken. Understood? No? So forward reaction, how can I draw? Super. Right. Okay, ma. So now see ma, at t is equal to 0. T is equal to 0 means here, no? Here, how many number of moles of reactant was there? 4 moles. It means I have to start from here. Okay. And at equilibrium? And at equilibrium, only 1 mole was present. It means graph should be somewhat like this. This is the shape of the graph, no? Understood, no? So what is this one? This is forward reaction which is happening. So it starts at 4, it ends at 1. Are you able to understand, ma? Now you go for the product. So at time is equal to 0, how much product is there? 0. It means I have to start from here. Okay, ma? And at equilibrium, how much product is present? 1.5 was present. And where is 1.5? 1.5 will be somewhere here. Understood, no, ma? It means how shall I draw the graph? So it means I have to draw the graph like this. Are you able to understand? Clear, no, ma? So, no, it should not exceed beyond that value. So graph will be somewhat like this. This is the graph. Understood, Nama? I think we can draw some more better. So graph can be like this. Understood, Nama? So what is this one? This is concentration of A and this is concentration of B. So see, where is that graph? B. B, na? So this is my answer. Understood, Nama? So just in this method, if you do the calculation, you will get initial number of moles and final number of moles. Then just to draw a graph of them, that is my required answer. Fine? That's it. Okay, so next we are studying about the constant of equilibrium, which is called as equilibrium constant. Clear? So consider this is a reaction. So N1 moles of A, it is converting into N2 moles of B. Are you able to understand, ma? So here the stoichiometric coefficient of reactant is N1, stoichiometric coefficient of product is N2. Then we define the equilibrium constant in 2 methods. Okay, ma? Equilibrium constant is defined in 2 methods. First method is in terms of mole concentration. Okay, ma? And second method is in terms of partial pressures. Okay? Are you able to understand, ma? So in terms of mole concentration and in terms of partial pressures, we will try to define this constant of equilibrium, which is called as equilibrium constant. So first one is in terms of mole concentration. Okay, ma? So there are many concentration units, no, ma? So for example, I can write the constant of equilibrium is equals to, if I take this relation, then I will write concentration of B to the power of N2 divided by concentration of A to the power of N1. Okay? So concentrations of A comma B, they should be in molarity. Okay? There are many concentration terms are there, no? Molarity is there, molality is there, clear? Normality is there, all these are there. So this is how I represent the equilibrium constant of a reaction. Are you able to understand? In terms of molarity. So what is meant by bracket of B, ma? Concentration of B. To the power of what? To the power of its stoichiometric coefficient. Okay, so here B is the product. So bracket of B means concentration of B. And to the power of what we have to write? We have to write to the power of the stoichiometric coefficient of the product divided by concentration of the reactant to the power of number of moles of reactant, or you can say stoichiometric coefficient of the reactant. Are you able to understand, ma? So this is first method of writing the equilibrium constant. Second method is equilibrium constant can also be written as partial pressure of B to the power of N2 divided by partial pressure of A to the power of N1. So I can write like this also. Okay. Now can you say what is meant by PA and what is meant by PB, ma? So the pressure exerted by gas B to the power of its stoichiometric coefficient divided by pressure exerted by gas A to the power of its stoichiometric coefficient. Are you able to understand? So also we can write a K equivalent is equals to Kf divided by Kb also. Okay. What is Kf here? Kf is called as rate constant in forward reaction, and Kb is called as rate constant in backward reaction. So you can write like this also. K equivalent is equals to Kf divided by Kb. Are you able to understand? So these are the methods of writing the equilibrium constant. Clear, ma? Completed? So next we study about factors on which this equilibrium constant depends upon. Okay, ma? Let us see. So factors on which equilibrium constant depends upon. Okay, ma? So equilibrium constant, it depends only on two factors, ma. Okay. So K equilibrium depends on only two factors. What are the factors, ma? Question can be asked on this one. First factor is temperature of gas or of the reaction. Second one is stoichiometric coefficient. Are you able to understand, ma? So equilibrium constant of any reaction, it depends only on two factors. One is temperature in which reaction is happening, and the second one is the stoichiometric coefficients. What are the stoichiometric coefficients which are present? Are you able to understand? So it does not depend upon how many factors. It does not depend on remaining all the factors. Okay, ma? For example, you can take pressure. Okay. You can take volume of container. Clear, ma? And also you can say concentration of reactants and products. Okay, ma? Concentration of reactants and products. Introduction of inert gas. Introduction of inert gas and all these factors. Okay. So the equilibrium constant doesn't depend on these factors, ma. Understood now what is happening? So it only depends on two factors and it never depends on other two factors, whatever may be the number of factors which are present. Okay. Now let us see what are the rules of calculating the equilibrium constant of a reaction in equilibrium. Okay. So rules to calculate equilibrium constant. Okay. So let us write rule number 1. Okay, ma? Rule number 1. So see here. Example, if I take N1A, it is reversible and it is forming N2B. This is the reaction. Okay, ma? N1 moles of A, it is reacting to become, or it is converting into N2 moles of B. So here A is the reactant, B is the product, N1 is the stoichiometric coefficient of the reactant, N2 is the stoichiometric coefficient of product. Are you able to understand, ma? And for this reaction, equilibrium constant, let it be K1. Okay, ma? Equilibrium let us take a K. Equilibrium constant of this reaction is what? K. Now this total reaction is multiplied by is multiplied by, okay ma, by what shall I multiply? Multiplied by any constant value. Okay. For example, I say P multiplied by N1A. So this is what is happening. Are you able to understand ma? So P can be any number ma. 2 moles, 3 moles, 4, anything. Are you able to understand? So if I multiply like this, same equation how I can write P N1A converts into P N2 into B. This is what is happening. So P can be anything, 2, 3, 4, 5, 6, 10, anything. Okay ma? Then the new equilibrium constant can be written as K to the power of P. This is the reaction which I have to write. Okay ma? So before multiplying, what was the equilibrium constant ma? It was K. And after multiplying by some number, what happened to the new equilibrium constant? It has become K to the power of P. Understood now what is happening? That's it. Make a note. So this is our rule number 1. Now let us study about rule number 2. Okay ma? Rule number 2. Let us see. Sima, consider N1A, it is convertible into N2B. Then in this condition, the equilibrium constant is K. Understood no? Same reaction if I perform it in opposite direction. That is, if I take N2B convertible into N1A. Are you able to understand ma? I am taking reverse reaction no? So in this condition, what is the equilibrium constant? It is equal to 1 by K. So this is rule number 2. Are you able to understand? So these rules you should remember very carefully ma, because many times direct questions were given on these reactions, on these rules of finding the equilibrium constant. Understood no? So if you are writing in one direction, that is N1A converting into N2B, okay ma, then the equilibrium constant is K. But if you write in reverse order, just if you take the reciprocal of the first reaction. Clear no ma? Then we study about rule number 3. Okay ma? So what is rule number 3? Let us consider A converts to B, B converts to C, C converts to D. Okay? Finally, I can say that A is converting into D no ma? A is converting into D. This is what is happening no? Okay ma? So A gives rise to B, B is reacting with something to give C, C is reacting something to give D. So finally, this is the reactant and final product is D in this condition. So for this particular reaction, the the equilibrium constant is K1, and for this reaction it is K2, and for the third reaction it is equal to K3. Then for the final reaction where A is directly converting into D, or through the steps it is converting into D, here I can write the equilibrium constant is equals to the product of K1 into K2 into K3. Okay ma? So this is our rule number 3. Are you able to understand what is happening? A converted to B, then the equilibrium constant is K1. B converted to C, equilibrium constant is K2. C converted to D, equilibrium constant is K3. Now if A to D, then what is the total equilibrium constant of this reaction? Then just you have to multiply all the equilibrium constants. Are you able to understand ma? But here we should be careful about one point ma. K4. దీన్నే K4 అంటాం కసుబక్క. The reaction, the equilibrium constant from A to D, you can call it as K4. And it is equal to the product of all the 3 reactions which we have performed previously. K1 into K2 into K3. Are you able to understand? So here, there is a very important point which you should keep in mind. Okay? What is that? Let us see. So note point is that the correct sequence of reactions should be followed. Correct sequence of reactions should be followed. Okay? So this is the most important point which you should remember. So what is the sequence of reactions? Those reactions must be exactly followed. Are you able to understand? See, for example, if this is the sequence of reactions which are done, this is the sequence of reactions which we are doing now, A to B, B to C, C to D, and finally A to D. Okay? If question is given like this, okay? For example, if question is given like this, A to B, the equilibrium constant is K1. Okay, ma? Then I write C to B, the equilibrium constant is K2. Then I will write C to D, the equilibrium constant is K3. Then what is the equilibrium constant from A to D? Okay, ma? So if I give a question like this, now can you say how can you solve it?
K1 into K3, sir.
Think carefully and answer. Sutti answer lottu. Okay, ma? Remember all the rules carefully and see what is the answer you will get. This is the original sequence, ma. Are you able to understand? And this is the given sequence. Is it clear? So, in this sequence, when compared to this sequence, so what is the equilibrium constant from A to D? That is my question. That is our answer. How you got 1 by K2, ma? Because this reaction is in reverse order, no? If I travel from B to C, then the equilibrium constant is K2. But here what is given? C to B is given, no? That is, it is given in reverse order. Then I have to take the 1 by, the reciprocal of this equilibrium constant. Are you able to understand, no? So therefore, instead of this reaction, what I can write? Instead of this reaction, I will write B converts to C. So the equilibrium constant will be 1 by K2. Are you able to understand? Now the correct sequence is followed, no? So therefore, what is the total equilibrium constant? So K equilibrium constant from A to D can be written as K1 into 1 by K2 into K3. So that is how we have to write the equilibrium constants. Understood, no? So if you remember these three rules, so all the questions which can be given can be solved with the help of these three rules. Are you able to understand? Now let us see one more example, completed up to here. So see. Okay. So let us write one more example. See, H2S, it converts into H plus and HS minus. Okay. So for this reaction, the equilibrium constant is K1. Clear, no? Then what is happening? HS minus, it is converting into H plus plus S2 minus. And for this one, the equilibrium constant is K2. And finally, H2S got converted into what? It converted into 2H plus plus S2 minus. And for this, what is the equilibrium constant? That is the question. Okay. See the sequence of steps, ma. If you see the sequence of steps, then you can understand what is happening in this condition. Okay. So H2S, hydrogen sulfide, it is getting converted into H plus and HS minus. So for this reaction, what is the equilibrium constant? It is K1. Are you able to understand? In the second step, HS plus, it is converting into another H plus and S2 minus. Now it is losing one more hydrogen number, so it will get one more negative charge. Are you able to understand? So S2 minus, and for this one, the reaction is K2. Okay. So therefore, H2S finally converted into how many products? Here there is one hydrogen which we got, no? Here there is one hydrogen number. And here we got one more hydrogen, no? That what about HS plus? This H plus only, it converted into these two values, no? Okay. So whatever product we have on the right hand side, and if there is a product on, if it is becoming reactant on left hand side, then you can cancel these two. Are you able to understand? Because this HS minus only, it has converted into these two products, no? Are you able to understand what is happening? So you need not consider these two. So what are the final products which are formed? One H, another H plus. So finally, 2H plus. And here what is the final value I got? S2 minus. Are you able to understand them? Now for this reaction, what is the equilibrium constant? Can you say? Same steps, no, ma. From this step, I got this one, and this step is again followed. So they are in the exact sequence. So I can write K is equals to K1 multiplied by K2. That's all. This is my equilibrium constant for the reaction. Are you able to understand, ma? So first this step, next followed by this step. Okay? And if you are directly writing the reaction, then this reaction is the sum of these two reactions only, no? And they are in the same order also. So definitely I can write K is equals to K1 into K2. Are you able to understand? Similarly, if instead of writing the reaction like this, if question would have given like this. Let us see what is the given question, ma. Okay? So see. So H2S converted into H plus plus HS minus. Okay? For this one, the equilibrium constant is K1. Okay, ma? Then H plus plus S2 minus, it got converted into HS minus. For this one, the equilibrium constant is K2. Clear, no, ma? And finally, H2S got converted into, so 2H plus plus S2 minus. And what is the equilibrium constant of this reaction?
K1
K1 into 1 by K2. That's all, no? So here, actually, this was the reaction which was given, no? When compared to this reaction, here the reaction is performed in opposite direction. And here, be careful, every reaction, it is reversible. We are studying only which kind of reactions? We are studying only reversible reactions only. Are you able to understand? So therefore, this equation, how can I write? This equation, I can write it as HS minus, so convertible H plus plus S2 minus. Clear? So for this one, the K value is 1 by K2. Clear, no? And this is the correct sequence, no? First one followed by second one, and this is the final result. Are you able to understand what is happening? So therefore, what is the total K value? Total equilibrium constant of the reaction, I can write it as K1 multiplied by 1 by K2. That's all. Understood now what is happening? So you have to follow always the correct sequence, ma'am. So if sequence is reversed, you just reverse the equilibrium constant also. That's it. Okay? Make a note. See, ma'am. So this is the reaction. So if the equilibrium constant of this is the given reaction, ma'am. Clear? So nitrogen and oxygen, they are forming to form 2NO. Okay? Then what is the equilibrium constant of this reaction? Okay? Can you say what is happening? So from this one, how can I compare this one and what is the equilibrium constant of the second one? So this total equation, it is multiplied by 1 by 2, no? That's all. Clear, no? 1 by 2 into N2, 1 by 2 N2, 1 by 2 into oxygen, 1 by 2 O2, 1 by 2 into 2 NO, NO. It means total reaction is multiplied by 1 by 2. So therefore, total reaction is multiplied by 1 by 2. So therefore, which rule we have to follow? We have to follow rule number 1. Okay, ma? What is rule number 1? Okay. So therefore, I will write K equilibrium is equals to K power 1 by 2. That's all. That is my answer. Understood, Nama? Original equilibrium coefficient, equilibrium constant is how much? It was K. So the constant multiplied is 1 by 2, no? So K power 1 by 2. That is our answer. Can I correct it? So Sima. Yeah, drilling Sima. So this is the given reaction. No, let us write the reactions first of all, then we will get an idea what is happening. So N2 plus O2, okay ma, it is giving 2NO. This is first reaction, and for this one the equilibrium constant is K1. That's all, no? And see what is the reaction. Second one, 2NO. Again it is getting reacted with oxygen. Clear ma? And what is the final product I got? It is 2NO, nitrogen dioxide. Okay ma? And for this one the K value is K2. This is the given question, no? Now if I sum up these total reactions, already I said you one rule, no ma? So here I have 2NO, here also I have 2NO, no? These two you can cancel. Already I said you know. Clear, no ma? Because this 2NO only again it is getting converted into other products. So you need not consider it. Are you able to understand? Because already it has converted into products. మళ్ళీ ఇంకోసారి తీసుకున్నట్టు డబుల్ రేట్లు తీసుకున్నట్లు అవుతుంది. Are you able to understand? Now if you cancel them, now see what is the total reaction N2. Okay ma? So here there is one oxygen, here there is one more oxygen which are getting reacted, no ma? So totally how much? 2O2, and they give rise to what? They give rise to 2NO2. This is the final reaction. Like if I sum up these two reactions, this is the reaction which I got. Are you able to understand? Clear now up to here? Okay. Now see what is the reaction. He is asking us to find out the K value. Reaction is NO2 getting converted into nitrogen and oxygen. It means exactly opposite of this reaction, no ma? So here the NO2 getting converted into nitrogen and oxygen. But what is the reaction we got here? Nitrogen and oxygen, if they combine, I will get 2NO2. Are you able to understand, no ma? So for this reaction initially, what is the K value? So for this reaction, the K value is, it is just the product of these two K values, no ma? Okay, because from these two only I got this relation. So therefore K is equals to K1 multiplied by K2. Up to here it is clear, no? Okay. But what is the given reaction? Given reaction is exactly opposite, no? Given reaction is exactly opposite. It means K value will become 1 by K1 multiplied by 1 by K2. We have to take reciprocal, no? So you take the reciprocal of K1, K2. What is the reciprocal of K1, K2? 1 by K1 multiplied by K2. Are you able to understand? Okay. Now you check the number of moles, ma. Check the number of moles here. See here, I have 2NO2. But here I have only 1 by 2, only 1 NO2. Clear, no? I have 1 nitrogen, half moles of nitrogen. Here I have 2 O2, only 1 mole of O2. It means this total reaction, if I multiply by 1 by 2, then I get this reaction. No? Are you able to understand? Ma? So if I am multiplying by 1 by 2, then what should be the power? Power should be 1 by K1, K2 multiplied by 1 by 2. That's all. That is how we do the calculation. Are you able to understand? Ma? So write down. So if the resultant, this is the resultant. If the resultant reaction is reversed, then we get the asked reaction. Therefore, what is the K value? It is 1 by K1 multiplied by K2. Okay. But still there is one more point. What is that? But number of moles are made half. Number of moles are made half, no? It means what is P value? P value is 1 by 2. Therefore, what is the final K value? Final K value is 1 by K1 multiplied by K2 to the power of P. P value is 1 by 2. So that is my answer. Understood, no? That's all. Clear? Okay, ma? Now see. So now we are trying to get a relation between Kp and Kc. So already we studied that equilibrium constant can be written in two methods. No? It can be written in terms of mole concentration also. It can be written in terms of partial pressures also. So this is how I write in terms of concentration terms. In terms of pressure terms, I can write like this. Okay. So the relation between them is Kp is equals to Kc multiplied by RT power of delta Ng. This is the reaction. Okay, ma? So very important relation between Kp and Kc. Okay. So what is meant by delta Ng? Already we have studied, no, ma? Delta Ng means what? Okay. So the difference of gaseous moles of products and reactants. Okay. This already we have studied, no? For example, 2 moles of A plus 3 moles of B, they are forming 1 mole of C plus 2 moles of D. Are you able to understand, no? This is the reaction. Then how can I calculate delta Ng? Delta Ng, how can I calculate, ma? So number of moles of products, how many? So here 1, no, C means 1C. So 1 plus 2 minus of number of moles of reactants are 2 plus 3. So 2 plus 3. Okay. So this is how we can calculate delta Ng value. Okay. So therefore the relation between Kp and Kc, this is the relation. Kp is equals to Kc multiplied by RT power of delta Ng. Okay. So here we can write some cases also. Cases are, first one, if delta Ng is equal to 0. Okay. So difference in number of gaseous moles of products and reactants if it is 0. Okay. So if delta Ng becomes 0, then can you say what will happen, ma? If delta Ng becomes 0, to this reaction, what happens? Can you say, anybody? Kp will become equal to Kc. That's all, no? Because we know that x power 0 or anything power 0 is 1. Clear, no, ma? So RT power of 0 also will be how much? It will become 1 only. Therefore, what I can write? Therefore, I can write Kp must be equal to Kc. So this is a relation. And questions were asked previously on these cases also. Understood, no, ma? So case number 2. Case number 2 is delta Ng if it is greater than 0. Okay. So see, ma, here in this condition delta Ng is less than 0, no? Similarly, if I write a case if delta Ng is greater than 0, it means the number of moles of products is greater than number of moles of reactants. Okay. Then in this condition, now can you say what is the relation? If delta Ng is greater than 1, then it is multiplied by RT, no, and RT value also will be greater than 1. Clear? So Kp must be greater than Kc. Clear? And what can be the rule number 3, ma? So delta Ng is less than 0. Okay. See, ma, correct this one. This is greater than, it is less than. Okay. Then in that condition, I have to write the opposite statement, no? Kp is less than Kc. So these are the 3 cases which you have to remember in the case of Kp as well as Kc. Clear, no? Let us write a small problem based on this one. Yes. So you have to represent the gaseous forms because here we are calculating delta Ng, no? Delta Ng means number of gaseous moles only. Are you able to understand? See, ma. So this is the question. So APMT 2010. Question ma? So see. So in which of the following cases Kp and Kc they are equal? Okay. So Kp and Kc will become equal in which condition? So only when delta Ng when it becomes 0, then I will get Kp and Kc to be equal. Clear nama? Now see in the first case. In first case, delta Ng is how much? See number of moles of products ma? So 1 mole of nitrogen, 1 mole of oxygen, 2 minus, and how many moles of nitrogen oxide? 2. Okay. So definitely here it is 0. So Kp and Kc are not equal ma? Not equal, not equal. Understood no? So B. So in B what is happening? How many moles of products are formed? So 2 moles. And how many moles of reactants are formed ma? They are also 2. So here also it is 0. Understood no? Okay. Clear no ma? Similarly you take C ma. So here also 2 moles of gaseous moles of products and 2 moles of reactants. So here also it is 0. What about D? 2 moles of products and how many moles of reactants? 2 plus 1, 3. So here it is. It is in solid form. Okay. So therefore it is equal to only 2 minus of 1. Okay ma? So see here. So here carbon it is present in solid form. You should not count this. Only those which are present in gaseous moles only we have to take. Clear no? So 2 minus 1 is how much? It is 1. So therefore this is our answer where Kp and Kc they are not equal. Clear no ma? That's it. Okay ma? So now let us see how we can calculate Kp and Kp values ma, when problems are given. So what is meant by equilibrium constant? Already we have written this one no? So the concentration of products to the power of its stoichiometric coefficient divided by concentration of reactants to the stoichiometric coefficient of reactants. Clear nama? So for example, if this is a reaction which we are taking, reversible reaction, so A converts into 2B. Clear nama? So stoichiometric coefficient of the reactant is 1, stoichiometric coefficient of the product is 2. Then Kc means what? Equilibrium constant in terms of molar concentration. No? C means concentration. Already we studied that. Concentration I can write in 2 terms. Equilibrium constant I can write in 2 terms. I can write in terms of concentration, I can write in terms of pressure also. So in terms of concentration, how I have to write concentration of products to the power of its stoichiometric coefficient divided by concentration of reactants to its stoichiometric coefficient. So B power, so what is the stoichiometric coefficient here? 2. And A is the reactant, no? So its stoichiometric coefficient is 1. So I can write in terms of partial pressures also, nama. So Pb is the partial pressure of product to the power of its stoichiometric coefficient divided by partial pressure of the reactants to its power of stoichiometric coefficient. That's it, nama. So in solving the problems, already we have to take 2 cases. I think already we have discussed this one. We are discussing once again. Okay. So in solving problems, always take 2 conditions. Okay. So what are the 2 conditions we have to take? First condition is at T is equal to 0. What is meant by T is equal to 0? When chemical reaction is about to start. That is called as time is equal to 0. So that is when reaction, okay, is about to start. Reaction is about to start. In this condition, you take T is equal to 0. Okay, ma? Second condition is at equilibrium. At equilibrium, you take the second condition. Are you able to understand, ma? So, for example, let us take this reaction here. So, A converts into 2B. Are you able to understand, ma? So, at time is equal to 0. Okay, ma? At T is equal to 0. What is meant by T is equal to 0? When the chemical reaction is about to start. At that reaction, so I can call how many number of moles of reactant is present. Let us consider A moles are present. Okay, ma? And reaction still it has not started, no? So products will be 0. There will not be any product. And are able to understand, ma? A is the number of moles, 0 is the number of moles of the products. So initially only reactant was there. There was no product. Clear? Then we write at equilibrium. Okay, ma? At equilibrium, I will write let it be A minus X. Now can you say what is meant by X here? At equilibrium, I have written A minus X. Okay, ma? What is the meaning of X here? X means what? X means the number of moles which have dissociated. Number of moles have disappeared. Okay, ma? So as the reaction progresses, what happens to the reactants, ma? Reactants will reduce, products will increase. This is what will happen. No? So X is the number of moles which has reduced in the case of reactants. Clear? Now can you say in terms of products, how can I write, ma? In terms of product, how can I write at equilibrium? How many moles would have developed? 2x moles would have developed. Understood, no? Why? Because that is the type of reaction which I am taking, no, ma? 1 mole of reactant converts into 2 moles of products. That is the type of reaction, no? Here how many moles are there? 1 mole. Converting into how many moles? 2 moles. Are you able to understand, ma? So therefore, X number of moles of the reactants have deteriorated, or you can say dissociated. Are you able to, or reduced, you can say. Then how many moles of product will form? 2 moles of product will form. Are you able to understand? So therefore, X value, how can I write here? X is nothing but, okay, ma? Number of moles reduced. X I can call it as number of moles which are reduced. Okay, ma? Or you can call it as, X is also called as extent of dissociation. Extent of dissociation. What is meant by extent of dissociation, ma? How many number of moles have dissociated in the reactants? That is called as X. Are you able to understand? So therefore, if I take the ratio X by A, then can you say what is the meaning of this one? X is what? Number of moles which have reduced or which have converted into products. Clear, number? A means what? Initial number of moles. A is initial number of moles, not a time is equal to 0. So X by A will give what? X by A will give degree of dissociation. Degree of dissociation. Are you able to understand, ma? So X by A is called what, ma? X by A is called as the degree of dissociation, or you can call it as factor of dissociation. Factor of dissociation. Are you able to understand? Now if I want percentage of dissociation, factor not, ma? Fraction of dissociation. Percentage of dissociation, if I calculate, then what I have to write, ma? See, ma, this X by A, it can also be called as alpha. X by A is also called as alpha, the degree of dissociation or the fraction of dissociation. Okay, so fraction multiplied by 100 is called percentage of dissociation. That's all, no? So therefore, X by A multiplied by 100 is called as the percentage of dissociation, or just you can write alpha multiplied by 100. This is called as percentage of dissociation. Okay, what is the amount of product which has dissociated by the time reaction reached equilibrium? That is called as alpha value. Are you able to understand, ma? So based on this calculations only, now we are going to do some very, very important problems, ma, which were repeated in the previous examinations. Is it clear what is happening? Right now. Okay, see, ma. See, this is the question based on the calculations of Kc and Kp, ma. Let us see the question. So, at 2800 Kelvin, 1 mole of sample of CO2. So, how many number of moles are given? Only 1 mole is given. 1 mole of sample of CO2 in a 1 liter container is 50% dissociated to carbon monoxide and oxygen at equilibrium. So, this is the chemical reaction which is given. Then, what is the Kc value for the reaction? For this reaction, Kc means what? Equilibrium constant in terms of molar concentration. Okay, ma? That value we are supposed to calculate. So let us see how I can do this one. See, ma. First of all, Kc, how can I calculate? This is how we have written, no? Concentration of products to the power of its stoichiometric coefficient divided by concentration of reactants. Okay, ma? To the power of its stoichiometric coefficients. Okay. Now here say what are the products which are formed? Carbon monoxide is also formed. Oxygen is also formed. That's all, no? How many moles of CO is formed, ma? 2 moles. So therefore its stoichiometric coefficient is 2. How many moles of oxygen is formed? 1. Only 1 mole of oxygen is formed. So therefore its stoichiometric coefficient is 1. So therefore how can I write concentration of CO to the power of 2 multiplied by concentration of O2 to the power of 1. This is how we have to write. Understood, no? So whatever may be the number of products which are created, you multiply all their concentrations with the power of its stoichiometric coefficient. That is the method of calculation. Understood, Amma? So divided by, what are the reactants? Reactants is only CO2 only, no? Are you able to understand, Ma? So concentration of CO2, how many moles of CO2? 2 moles. So this is what we are supposed to do at equilibrium. And every calculation should be at equilibrium only, no? Because this is equilibrium constant. Understood? Now let us see. So first of all, let us take the given relation, Ma. So 2CO2 gaseous forms I am not writing. Okay, Ma? So it has converted into 2CO plus O2. Okay, so already we studied that we have to take two cases, no? What is the first case? At t is equal to 0. So write that case. So at t is equal to 0, that is when reaction is about to start. Okay, how many moles of CO2 is taken? 1 mole of CO2 is taken. How many moles? Okay, ma? Now see. So therefore, 1 mole of CO2 was present initially, 0 moles of carbon monoxide and 0 moles of oxygen was present at t is equal to 0. Okay, ma? At equilibrium, he gave that 50% of CO2 is dissociated. No? So 50% means, now can you say, how can I write at equilibrium? Ma? 1 minus? 1 minus? 1 minus 1 by 2 days. What is 50% of 1 half? No? So 1 minus 1 by 2. Okay, ma? So therefore, 2 moles of CO2 was converted into these products, no, ma? So it means it is half mole if it is reduced. Now can you say what will be the amount of carbon monoxide which is formed, ma? Huh? So this is also half only. Half mole only. Half mole has reduced, no? Half mole will be formed. Why? 2 moles have reduced. 2 moles should form, no? Are you able to understand how we are proceeding? Sima, how many moles of CO2 has reduced? How many moles of CO2 is present in the reaction? 2. So therefore, carbon monoxide also 2 moles only should form, no? So therefore, if half mole is reduced, here also half mole should be formed. Are you able to understand? Now what about oxygen? What about oxygen? How much amount of oxygen would have formed if half of carbon dioxide is reduced? Half of 1 by 2, half of 1 by 2 is 1 by 4, no, ma? Why 1 by 4? If 2 moles get reduced, here also 2 moles should form, but oxygen only 1 mole should form. Stoichiometric coefficient chustante artham avadam leda? This is 2, this is 2, this is 1. If this is reduced by 1 mole of carbon monoxide should form, and only half mole of oxygen should form. Artham avadam leda? LKG lekkal ra ivi. Idi kuda artham kagalapothe cheppanu inga class lo. మామూలుగా లేదు డబ్బి చేయలేదు మామూలుగా అంతేగా 2 moles of carbon dioxide is reduced, no, ma? Then 2 moles of carbon monoxide also should form, but only 1 mole of oxygen should form, because what is the stoichiometric coefficient? Only 1 mole is there, no? 1 mole should form. Are you able to understand? So here half mole is reduced because 50% is reduced, no? So half mole is reduced, 1 minus 1 by 2. If half mole is reduced, how many moles of carbon monoxide should form? Half only, because 2 and 2 they are same, no? But how many moles of oxygen should form? Half of that. So half of 1 by 2, only 1 by 4 mole should form. And these are the final concentrations. Initial concentrations are 1, 0, 0. Final concentrations are 1 by 2, 1 by 2, 1 by 4. Are you able to understand, ma? 1 minus 1 by 2? 1 by 1 minus 1 by 2, 1 by 2 only. Are you able to understand, ma? Now just substitute in this relation. Okay? Concentrations, final concentrations I got, no? So, what is the concentration of carbon monoxide? Half only. So, 1 by 2 to the power of what? Its stoichiometric coefficient is 2. Are you able to understand? Multiplied by oxygen. How many number of oxygen is formed? 1 by 4. What is its stoichiometric coefficient? 1. Divided by how many moles of carbon monoxide is present now? Only 1 by 2 is present, because 1 by 2 is already, it has dissociated, no? Now only 1 by 2 is present. So, 1 by 2. What is its stoichiometric coefficient? 2. Are you able to understand? So therefore 1 by 2 power 2, 1 by 2 power 2 get cancelled. So I will get 1 by 4, which is equals to 0.25. So this is the K value of this reaction at equilibrium. Are you able to understand? That's all very simple. Okay, ma? Okay. So let us see this question, ma? So a reaction is given. A plus 2B converts into 2C plus O. Okay, ma? So 2C plus D, I think, not it is not O, it is D. 2C plus D. General reaction he gave. And all of them they are in gaseous form. So this reaction is studied and it is observed that initial concentration of B was 1.5 that of A. It means concentration of B is 1.5 times when compared to concentration of A. Okay. Then what he is asking, but at equilibrium, concentration of A and B were found to be equal. But as the reaction progressed, so concentration of A and B, they were found to be same at equilibrium. Then what is the Kp value for the equilibrium? What is the Kp value at equilibrium that we are supposed to calculate? Okay, now see. So therefore, let us write the reaction. So A plus 2B converting into, clear ma? 2C plus D. This is the reaction. No? So initially concentration of B was 1.5 times that of A. So if I take a concentration of at T is equal to 0, if I take concentration of A, then concentration of B was 1.5. No? This is the meaning of this one. No? When compared to concentration of A, it was 1.5. Are you able to understand? And at T is equal to 0, concentration of C and concentration of D, they will be 0. So, barabar, inali. Okay, ma? Here only reactants will be there, no? Products will be 0 before the starting of the reaction. Okay. Now, what is the second case I have to write? Second case is at equilibrium. Okay. So, at equilibrium, let us consider 1 minus X moles of A has dissociated. Are you able to understand, ma? Then how many moles of B would have dissociated, ma? Can you say 1.5 minus 2X. 2X we have to write. Why 2X? Because initially 1 mole of A should react with 2 moles of B, no? 1 mole of A reacts with 2 moles of B. So if X moles of A will dissociate, 2X moles of B should dissociate. That is what should happen. Understood, no? And what is 2C here? 2 moles of C is formed, no, ma? So therefore how much X will be there? 2X. That's all, no? What about D? D will be X because there is only 1 mole. Are you able to understand, ma, how we have to write the reactions? Clear, no? Everything depends upon stoichiometric coefficients, ma. Because at the starting only I said, you know, Kp and Kc values, they depend on what? They depend only on temperature and this stoichiometric coefficients. Are you able to understand, ma? Okay. Then one more point he gave, ma. But the equilibrium concentration of A and B, they were found to be equal. So these are the concentrations at equilibrium, no? So these values, they were found to be equal. So what is the meaning of this one? I will write 1 minus X should have been equal to 1.5 minus 2X. That is the meaning of this one, no? Concentration of this reaction of A and B, they were equal at equilibrium. Now do the calculation. So 2X minus X is X. X is equals to 1.5 minus 1 is how much? 0.5, which can also be written as 1 by 2. Clear? So that is X value. It means a half mole of A is reduced, 1 mole of 2B is reduced, 2 moles of X value 1 by 2 nama, 1 mole of C is formed and a half mole of D is formed. That is the meaning of it. Now substitute. So 1 minus 1 by 2. This is 1.5 minus 2 into 1 by 2. So this is 2 into 1 by 2 and this is 1 by 2 because X value is 1 by 2. Are you able to understand? Ashish, Venatam ledo. So therefore 1 by 2 and this is how much? 1.5 minus 1. This is also 1 by 2 and this is 1 and this is 1 by 2. Satisfied, no? So these are the respective concentrations at equilibrium. At equilibrium these concentrations are present. Now substitute in the equation of pressure Kp. Kp how can I write, ma? So this is the equilibrium constant in terms of pressure, no? So how can I write this one? So pressure of C to the power of its stoichiometric coefficient multiplied by pressure of D to the power of its stoichiometric coefficient divided by power of A to the power of its stoichiometric coefficient multiplied by power of B to the power of its stoichiometric coefficients. Pressure of A, pressure of B. Power anana? Very good. Are you able to understand, ma? Physics buddhi anta easy ga poda anamata. Okay, ma. Now we have calculated number of moles, no, ma? But the equation is in terms of pressure. So how can I do? అర్థం కాలేదు ఇంకోసారి చెప్పరా. ఓహో, టెంపరేచర్ ఇస్ నాట్ గివెన్. క్వశ్చన్లో టెంపరేచర్ ఇచ్చినాడా? Temperature is not given. There is a relation between Kp and Kc, but temperature is not given. No, we cannot do that calculation. Any other method? Here I have final concentrations, ma. It means final number of moles are present at equilibrium. But here everything is given in terms of partial pressures of the gases. Okay? How can I calculate? Anybody? See, already we studied one relation, no? What is the number of moles? What is the fraction of moles? Same is the fraction of pressure also. Do you remember? Gurtunda? Gurtuledu. Clear ma? So, PA divided by PB is equals to NA divided by NB. Do you remember this one? Pressure is given by whom? Pressure is given by molecules only, no? If number of moles increases, pressure also increases. So what is the pressure ratio? Same is the mole ratio also. ఇప్పటికి 14 లెక్కలు చేస్తున్నాం దీనిపైన మనం. ఇట్లా వినడం అట్లా వదిలేయడం ఎట్టయితే ఎట్లా. ఓకే, సో వాట్ ఈస్ ద మోల్ రేషియో? సేమ్ విల్ బి ద pressure ratio also. Already we discussed, no? So this is also division only, no? So it means instead of pressures, directly you can write number of moles, because as number of moles increases, pressure also increases. That is the meaning of it. Okay, so therefore what shall I write? Completed this one? I will write here. So therefore what I can write, therefore, and here all the gases, they are present in same container, no? As all gases are present in same container. All gases, they are present in same container. The fraction of number of moles will be equal to fraction of pressure, or fraction, or you can say the ratio of number of moles will be equal to ratio of moles is equal to ratio of pressure. Understood, ma? So just to substitute. Okay, so Kp value, how can I write? What is the pressure of C to the power of 2, no, ma? What is the number of moles of C? 1. So 1 power 2. Clear? How many number of moles of D is formed? 1 by 2. So 1 by 2 power 1 divided by number of moles of A? 1 by 2. 1 by 2 power 1. And the number of moles of B? 1 by 2. So 1 by 2 power 1. 1 by 2 power 2, na? 1 by 2 power 2. That's it. Clear, no? So 1 by 2 get cancelled. So therefore 1 by 4 is 4. So Kp value is how much, ma? Kp value is 4 for this reaction. Understood how we have calculated? So everything is based on this concept, ma. Conceptual clarity undali. That's it. Okay, ma? So look at the next question, ma. In an experiment starting with 1 mole C2H5OH and 1 mole CH3COOH and 1 mole of water is also present, ma. The equilibrium mixture on analysis shows that 54.3% of acid is esterified. It means this much amount of acid it has reduced. That is the meaning of this one. So calculate Kc for the reaction. So let us see how we can proceed. First of all, let us write what is the reaction which is happening, ma. C2H5OH plus CH3COOH. So if they react with each other, then they form CH3COO C2H5 plus H2O. So this is the reaction which should form. Are able to understand, ma? So this is called as esterification. The reaction between alcohol and acid is called as esterification. Are able to understand? Now see, ma, initially how many moles of C2H5OH was present? So at T is equal to 0, this was 1 mole, no? How many moles of CH3COOH? This is also 1 mole. Okay, and what about this product? 0. What about water?
0.
Water was 1. It is already given, no? 1 mole of water was also present in the reaction. Are able to understand? Okay. Now what is happening at equilibrium? Some of the acid is esterified. It means this much amount of acid, it has been reduced, dissociated. Are able to understand? Now here value is given in terms of percentage, no, ma? So what do you mean by percentage? Percentage means alpha value, no? Do you remember? Alpha into 100 is how much? It is 54.3, which can also be written as x by A multiplied by 100. Do you remember this one? And from this one we are supposed to calculate x value. X value means how many moles have dissociated. Okay, alpha is given, percentage alpha is given. So this is how we have to write, no, ma? So therefore x value, how can I write? X value is equals to 54.3 multiplied by A divided by 100. What is A? A is what? Initial number of moles. How many initial number of moles? Only 1. So therefore it is 54.3 divided by 100 is how much? 0.543. That's all. Understood, no ma? Okay. Now at equilibrium we will write. At equilibrium. Okay, ma? So at equilibrium what should happen? Let us write in terms of general terms. 1 minus x. So here also 1 minus x only, no? Clear, no ma? Because 1 mole of C2H5OH is reacting with 1 mole of CH3COOH. So what is the number of moles dissociated in this one? Same number of moles will be reduced in this acid also. Are you able to understand? Clear? And what about this one? Here X moles will be formed, no? Because for every 1 mole of product should be formed. And what about water? Water also I have to write 1 plus X, no? Already there was 1 mole. Additionally, X moles was formed. Okay. So X value already we have calculated, no? So substitute here. Once you substitute here, then can't you calculate Kc value? No? That's all. Do the calculation. Okay, ma? So therefore substitute 0.543 instead of X, ma. Okay. So therefore it is 1 minus 0.543. 1 minus 0.543. This is 0.543 and this is 1 plus 0.543. So 1 minus 0.543, 0.457. So this is also 0.457. This is 0.543. This is 1.543. That's all, no? So concentrations I have calculated, no? Final concentrations. Now just calculate Kp value. Kp na Kc na? Kc value. Okay. So Kc value how can I calculate, ma? So concentration of this one is how much? So 0.543, and what is the stoichiometric coefficient? 1 multiplied by H2O 1.543, number of moles is 1, divided by reactant is C2H5OH, so 0.457 to the power of 1, and this is also 0.457 to the power of 1. So just do this calculation. That is our answer for Kc, equilibrium constant at molar concentration. నేను కూడా రియాక్షన్కే చేసినారా? Okay. Sima. So the equilibrium constant for the given reaction is, this is the given reaction, 2SO2 plus O2 gives rise to 2SO3. Okay. So what is the equilibrium constant, ma? Equilibrium constant is given as 3.5. Okay. It is Kc. Kc value is 3.5. Okay. Kp value only, no? Okay. Kp, partial pressure, he is asking Kp. So what would be the partial pressure of oxygen gas if at equilibrium it is found to have equal moles of SO2 and SO3? It means at T is equal to 0, okay ma? At T is equal to 0, how many number of moles are there? We don't have any information. Are you able to understand? At T is equal to 0, that is how many moles have reacted with how many moles, we don't have any information. So you need not write that also. Okay. So at T is equal to 0, how many number of moles are there? We don't have any idea. But we know how many number of moles are there at equilibrium. At equilibrium what he gave? Equal number of moles of SO2 and SO3. So therefore you do one thing. So you write n moles of SO2 is there and n moles of SO3 is also present. Okay. So n moles of SO2, n moles of SO3. And how many moles of O2 is present? That also I don't know. Okay. Any information is not given. So therefore let us see how we can proceed in this problem. So how can I write Kp value, ma? Kp value how can I write? So concentration of SO3 to the power of 2 divided by concentration of SO2 to the power of 2 multiplied by concentration of O2 to the power of 1. This is how I have to write, no? Clear, no, ma? And see here, SO2 and SO3, same number of moles are present, no? If number of moles are same, their partial pressures also will be same only. Because already we have studied, no? So what is the number of mole ratio? So SO3 divided by n SO2, same will be the partial pressure ratio also. This point you should never forget because they are present in the same container only, no ma? Container is also not different, no? Same container. So therefore what is the ratio of moles? Same will be the ratio of pressures also. Are you able to understand? So he is asking pressures, no ma? So I will write like this: PSO3, PSO2, partial pressure of SO2 and partial pressure of O2. I can write like this. Okay. So as number of moles are same, partial pressures also will be same, and stoichiometric coefficient powers also they are same, no? So therefore, can't you cancel these two, no? I can cancel them, no? So therefore, Kp value already given, no? What is Kp value? 3.5 is equals to 1 by the partial pressure of oxygen. Clear, no? So therefore, what is the partial pressure of oxygen? It is just 1 by 3.5. So just do this calculation. That is my required answer. That's all. Board me cheyadaniki nimisham pattaledu. Have you understood, ma? So what are the number of moles at T? I don't know. What is the concentration of O2? That also I don't know. But still we are able to solve the problem, no? Huh? That's it. So 1 by 3.5 approximately 0.28 something I think we will get. So 0.287 or 285. See what is the calculation. Let us see. See, ma. So this is the given question, ma. So value of an equilibrium constant for a particular reaction is 16 into 10 power 15. So equilibrium constant is 16 into 10 power 12. Okay. Then the system will contain what? So all reactants, mostly products, mostly reactants, same amount of reactant and product. Okay. So what is meant by equilibrium constant? It is the concentration of products power N2 divided by concentration of reactants power of N1. This is the equation of K equilibrium, nama? Now see here. What is the K value given? 16 into 10 power 12. That's all, no? Now we have solved many problems on Kp and Kc, no? All the values were 2, 2.5, clear? 4, 2.85. These were the values which we got, no? Abega the Kp, Kc values we got. But here see what is the K value I got? 16 into 10 power 12. Big value or very small value or very big value? Very, very, very big value, no? It means when compared to the reactants, products should be very large in number. Okay? It means that reaction is almost 100% completed. That is the meaning of this one. Okay, ma? Reaction, you cannot say 100% it is completed. Almost it is 100% completed because reversible process also will be there, no? Products, they will be again forming the reactants also. Okay, but process you can say almost it is 100% completed because if this value should be very large, then the concentration of products should be very large. If numerator increases, then only this value increases, no? It means concentration of products is very large. So therefore, definitely I can say the answer is mostly products. That's it. Very simple. Okay.
Mostly products or mostly reactants, sir. Both and
reactants are almost completed. Reactants have become almost zero. No reactants. In the numerator, what you have? Reactants you have or products? Products is there. It means all the reactants they have dissociated. And now only products are there. Then only numerator will be larger. Then only our K value will be larger. Clear? That's it. Sima. See this question. So alpha is the fraction of Hi dissociated at equilibrium and this is the reaction. So 2Hi dissociated into hydrogen plus iodine. Clear? So initially how many moles of Hi was present? 2 moles were present. Then the number of moles of reactants and products at equilibrium. It means how many number of moles of reactants and how many moles of products. Both we have to add and we have to see which one of the options is correct. Clear? Let us proceed. First he gave alpha value, no? Alpha is nothing but x by a, no? What is alpha? Fraction of dissociation. Fraction of dissociation x by a already we have written in the equation, no? So from this I need to calculate x value. And what is x? X is nothing but extent of dissociation or number of moles which have dissociated. Okay? So x is equals to a into alpha. That's all, no? What is a? A is nothing but number of moles. Initial number of moles of reactants. Clear? X is number of moles reduced. This terminology you should not forget, ma. Number of moles reduced. And alpha is called as fraction of dissociation. Fraction of dissociation. Are you able to understand? Okay. Now write down. So therefore, first of all, let us write the reaction, ma. So 2Hi, it dissociates into H2 plus I2. This is the given reaction, no? So again we have to write two conditions, no? At T is equal to 0, first condition. Initially 2 moles were there. 0 moles of H2, 0 moles of iodine. Products will not be there, no? Only reactants will be there initially. Clear, no? Then at equilibrium, okay, at equilibrium let us consider X moles have dissociated. Then how many moles of hydrogen will form? X by 2 will form, that's all, no? Because 2 moles if they dissociate, only 1 mole of hydrogen will form. So if X moles are dissociated, X by 2 moles, only half moles will form out of hydrogen. And how many moles of I2? This is also X by 2. Are you able to understand, ma? Now substitute. Okay. We shall do the calculation here. So therefore, 2 minus X, X by 2 and X by 2. These are the final number of moles at equilibrium. Okay. And X value already I have calculated. Now what is X value? A into alpha. So substitute. So 2 minus A into alpha. Okay, ma? A value was initially 2, no? So therefore I will do one thing, ma? Instead of here only I will substitute. So X is equals to 2 into alpha. I can write like this, no? Because A is initial number of moles. Initial number of moles. Initial number of moles are 2. 2 only, no? 2. So X is equal to 2 alpha. So I will write 2 minus 2 alpha, and here 2 alpha divided by 2, here also 2 alpha divided by 2. That's all. Just add them, then you will get the final number of moles. Therefore, final number of moles of reactants and products is how much? So 2 minus 2 alpha plus alpha plus alpha. So therefore it is 2. So finally 2 moles of reactants and products is formed. Clear?